This task is about anatomic notation and algorithm complexity. In the first question, we are asked to calculate worst case scenario, which is the case where every single line of the code, every single step of the algorithm will get executed. So we just sum up everything, uh, every single step, and that will be our worst case. And wherever there's a random chance, we just assume that we got unlucky and will the worst possible thing will happen to us. So everything will run. So after that, we just add everything up, and uh, then we'll get the worst case, the number of steps that we take. Then the next question, big theta notation for best worst average case. What's the tightest bound of this everything? The worst, best, and average case. The to calculate the tightest bound is just one equation. So in this case, we'll just see the maximum degree variable. In this case, for example, it's n. This case, it's n square and log n. So that will be our answer. Next question. Describe each algorithm's overall performance using the tightest possible big O notation. What big O notation is it's the upper bound of our algorithm. So our algorithm will never perform worse than the upper bound. To calculate the tightest possible upper bound, we'll refer to the worst case, and then we'll be taking the tightest of again we'll look at that equation for the worst case, and we'll see what's the maximum degree is, and we'll get the upper bound. And for the lower bound, which I think is the next question, big omega, which is the lowest bound. So we'll see it the bound at to which the algorithm cannot perform better. So the best it can do. So we'll look at the best case, and again same steps. So that's how we'll calculate the omega. And for the big theta notation, so as you can see in big theta notation, it's not always possible to calculate big theta notation. It's only possible in the cases where the big maximum and the minimum, I mean big O and big omega notation is of the same bound, same behavior. So if it's the big O is n square, the big omega should be also be n square, and we say that big theta will be n square. So that's how it works. So if we imagine a graph of that case, the only difference between the upper bound and lower bound will be the constant. So the whole algorithm will be between those two curves. Essentially, that's it. Algorithm, the most common example we go discuss commonly. Big O notation is more widely used because it gives us the worst possible case. More times than not very often, but still more times than not, it's like we want to see how the algorithm will perform in the worst case. So that's why it's preferred. Is it true that big is it true that big is it true that theta and square algorithm always take longer to run than algorithm? No, it's not always true. As you can see from this graph, this algorithm starts performing, the blue one starts performing better after a certain value, and before that the red one was performing better. And also depending on what, uh, because these graphs, all the notations, all the asymptomatic values donate the behavior of the algorithms, not the actual graph. So it's possible that what constant that is at the prefix of whatever the maximum, or every single prefix of like every single variable of the equation will have an effect on the overall outcome. So this is possible that this graphs might cross it after some a number of time, intersects a few times. So it's not always true that that n square will always take longer, depending on what follows it after the n square, and also the constant before the n square. So whether the whole for this, it's true because we can see in this case n square, largest degree is square, so we take that, and n is less than that. So this one is false because the big O notation of this should be n log n, and it's n here. So since n denotes the upper bound, the n log n will be performing a bit worse than that. So hence it's false. N square plus n is n cube. No, that's false. It's and if it is true, then it would be n square, but we're not sure. We also need to see what the lower bound is. N log n omega of n square of n. Yes, this is true because even though it's not a tight bound, it is true because omega donates the lower bound. So even if it less is loosely bound, but it's still true. So in short, the answer would be that, because everything, all the algorithm will be above that threshold.